So a quick review of our agenda. We are going to discuss the code revision process, which is based on a committee of stakeholders from the public. We will also talk about the impact and timeline of the code revision. And then we will get into the discussion on the provisions that we have adopted in the 2020 New York City Energy Conservation Code. So we'll talk first about those from the state code, those changes that came from the stretch code, and then changes that were made locally. Emily will walk us through all of the changes to the resources on the DOB website, how forms have been updated, and then we'll talk about how the code will change in the future. So to get us started, let's talk about the revision process. First of all, if you're familiar with our construction code revision process, the building and construction codes are subject to a carve-out at the state under the New York State Executive Law. That allows New York City to have our own code because we are a city with a population greater than 1 million. But the energy code is not covered under the New York State Executive Law. It's covered under the New York State Energy Law, and that law says that any municipality in the state can have their own energy code as long as it is more stringent than the state's code. So in addition to the ability and authority to have our own code, City Council determined in 2009 under Local Law 85 that we should have our own code in New York City. And so effective July 1st, 2010, New York City established the first energy code, so we are now coming up on 10 years of our own code in New York City. Also affecting our revision process for the 2020 code was Local Law 32 of 2018. That law said that Department of Buildings had to adopt provisions that brought the code in alignment with the New York Stretch Code if it was developed. The Stretch Code was developed by NYSERDA, New York State Energy and Research and Development Authority, and was published in July of 2019. So that code targeted an energy reduction of 20% compared to ASHRAE 90.1 2013, advancing the New York City Code well beyond the national model code. DOB staff actually participated in the development of the New York Stretch Energy Code, and in working with others, we worked to try and achieve that 20% reduction, but we're only able to achieve an 11.3 energy savings compared to the 2020 New York State Energy Code. So we didn't get to 20%, but this is still a major improvement. Now, the Energy Code is developed with the support of two advisory committees. There's a committee for the commercial provisions, and there is a committee for residential. The committee members are selected from an open call. And if this sounds like interesting work, you should pay attention to our website because we will be making that call again soon for our next code. There are also changes that are proposed by DOB staff, but from the committee members, there were 77 proposed residential changes and 260 proposed commercial changes. Not all of these were adopted, so we will be reviewing the major changes that were made by the committees. Then a proposed bill goes to council that includes all of the changes approved by Commissioner LaRocca. Let's talk about the timeline and how this impacts projects. In December of 2019, New York State's Code Council voted to adopt and then further amended the 2018 IECC and ASHRAE 90.1 2016. So these serve as the basis of the code in New York City. So at the foundation of our code is the New York State Code. And then we adopted portions of the NYSERDA Stretch Code, not the entire code. and added, in addition to those, the local changes from our DOB Energy Code Committee process. We also go through and make sure that legacy changes from the New York City Energy Conservation Code are preserved from previous code versions. All of these are integrated into one code. So the net effect of adopting the 2018 IECC and ASHRAE, which served the foundation of the state code, was that it increased commercial building efficiency by about 8% and increased residential energy efficiency by only about 2% compared to the 2015 IECC. The net effect of adopting the NYSERDA Code 2020 version increased commercial building energy efficiency by about 5% more than the state's code. So approximately 13% more than ASHRAE 90.1 2013. The residential energy efficiency, however, in adopting the stretch code, increased efficiency by about 19% more than the 2016 version of the New York City Energy Code. So these are dramatic changes for both commercial and residential. The effective date of the code is May 12th, 2020. And in determining what code your projects are subject to, you could refer to Buildings Bulletin 2 of 2020, which clarifies how the 2020 New York City Energy Code applies to projects. If a project was filed prior to May 12th, 2020, and had a complete application, it is subject to the 2016 Energy Code. When we talk about complete, we mean that the architectural, structural, lighting, and energy analysis must be included in that package. For boiler and mechanical aspects of that project, they can be filed later in DOB now. But approval will not be given to the project until all of the disciplines are reviewed and approved by the Energy Code team. Again, there are several resources that have been updated, and Emily will review these in detail later in the presentation, but you should look for updated forms for the TR8, the EN1 energy analysis form. Supporting our code are updates to rules 5000-01, 02, and some changes to 101-07. And in using resources to support your design process, ComCheck and ResCheck are updated and are 2020 New York City Energy Conservation Code specific versions. So please make sure that when you are using ComCheck and ResCheck, you are using the New York City version, 2020 NYCECC. In addition, we've updated bulletins 7, 8, and 9 of 2020 that help you determine how to apply the code to existing building alterations. On our website, we have a supporting documents how-to guide, which has been updated to support the 2020 code. It's really useful when you're working on your project to prepare for review at the department. There are training modules on our website about the aspects of the code. They're in process of being updated to the 2020 code. And our 2020 New York City Energy Conservation Code is available for purchase from the IECC on their website. The integrated code, however, is available on our website for free. You can access it and review it at any time. Unfortunately, it cannot print from our online version. Now that you understand how our process of updating the code works, I'm going to hand it off to Emily to walk you through some of our new provisions in the code.
Good morning, everyone. And thank you to Gina for walking us through how our energy code becomes updated. So now I'm going to get into the technical aspects of what changed in the code. So what I will be going over and what Gina will be going over later are the changes from the 2016 to the 2020 code. So it does not include all of the requirements of the 2020 energy code. It just highlights some of the major changes. And like Gina said, we've broken it down into where the code provision originated from, whether it originated from the state code, the stretch code, or our advisory committee. So at the state level, there really weren't very many changes. For the envelope, really just, the major change was that all heated slabs now must be insulated with R5 insulation that's beneath the slab. And a heated slab means that there's some sort of heating element within the slab, like hydronic heating coil embedded in the slab. So that was the major insulation change that happened. And also in the envelope changes, we clarified when and how airspaces may be included into the wall assembly U-factor calculations. So this was always a reference that was embedded within Appendix A of ASHRAE 90.1, but now it's specifically called out within the text within the body of the NYCECC. So we feel that that's a really good clarification for users. We got a lot of questions on that. So it doesn't change the stringency of the code or how we really apply it, but it just provides a little bit more clarification on how airspaces should be used. So that was really, those are the big changes on the envelope section. And I should back up just a second. And, for this presentation, we're going over the changes to the commercial energy code. Just a refresher for you, for those of you who don't use the energy code every day, the commercial provisions apply to any building that is greater than 3 stories, even a single family home. So the residential provisions, which we'll be talking about at 3 o'clock this afternoon, is for any residential occupancy 3 stories and less. So just keep that in mind when we're going over these changes. All right, so back to the technical changes. So for the HVAC equipment, there really also weren't many changes to the efficiency. However, the entire section was reorganized. So pretty much every code section changed from the 2016 to the 2020 code. On our website, on our energy code page, we do have a lot of resources at the bottom of the page. And in there, we have an analysis of code sections. So we listed all of the 2016 code sections and the analogous provision in the 2020 code. So, if you're one of those people that remembers code sections and you're going to the 2020 and you're remembering that, the economizer section was in C4 3.3 and you look there and it's not there anymore, it doesn't mean that there's no more economizer provisions. It just moved to a different section. So, definitely check out that resource on our webpage to see what's new, what new sections are, and how they correlate to the 2016. As far as efficiency increases, there weren't many. The biggest change was that for small residential size furnaces, there was a small increase in efficiency there. So, that may apply to smaller residential buildings. There was a change in the economizer requirements. This was probably the question or the code section that we got the most questions on for the 2016 code. And the way that code was written, it forced a lot of projects into using the ASHRAE compliance path because the economizer section was very stringent. So the state code, which adopted the 2018 IECC, relaxed those provisions for Group R occupancies. So, the economizer requirements are the same for other than Group R occupancies. Essentially, any Any cooling system greater than 54,000 BTU must have an economizer. And then for buildings other than Group R occupancies, the total system capacity without economizers, even if they're less than 54,000 BTU, cannot exceed an aggregate capacity of 300,000 BTU, or 20% of the total supply capacity. So that's what the 2016 code said, and that is still the same for the 2020 code in other than Group R occupancies. Now the change comes in Group R occupancy buildings, so your residential, your hotel. Individual systems that are less than 270,000 BTU are not required to have an economizer. So that increases the threshold of individual systems that don't require an economizer. And however, there still is an aggregate capacity on when economizers are required. So, but this increases from 300,000 BTU in other than Group R occupancies to 1.5 million BTU in the Group R occupancies. So, you know, a lot of residential buildings will now be able to comply under the ECC because of this relaxation under Group R occupancies. There is another provision. So, you know, we've also gotten some questions so far regarding the 2020 code that, you know, a lot of buildings would still be pushed into the ASHRAE provisions because of the Group R requirement you still have an aggregate capacity of 1.5 million, you know, that can not be without an economizer. But there's an important exception that was added. So there's an exception now that says you don't have to do any economizer on any equipment, regardless of the size, as long as it has a 20% efficiency improvement over the code minimum values. So you have high efficiency equipment in your building, you do not have to do an economizer. Has to be 20% improvement over the code minimum, and that's the EER value, not the IEER. So it's the full rated value, not the part load value. ASHRAE, it allows either one, but ECC only allows the full load value. Other changes in the HVAC section, there was some alignment with the 2018 IECC with ASHRAE 90.1. If you're familiar with the 2016 code, hotel guest rooms required occupancy controls on the temperature settings, right? So when the room was not occupied, the temperature had to automatically set back within the hotel room. ASHRAE now added a ventilation control, saying that the ventilation had to be shut off when there were no occupants within that within the hotel room after X amount of time. So that was just alignment with ASHRAE 90.1, taking that language directly over. Also, vestibule heating and cooling controls were brought over from 90.1 into the ECC. So now there's alignment there. So for vestibules, the heating set point cannot exceed 60 degrees Fahrenheit. And the cooling set point in vestibules cannot go below 85 degrees set point. And then for integral heating systems, whenever the outdoor temperature is greater than 45 degrees, it has to shut off. So really, this is just preventing overheating and overcooling within vestibules, and again, aligning with 90.1. So those were the highlights of the changes from the state code for HVAC. In the lighting section, you know, in the 2016 code, high efficacy lighting fixtures were required for 75% of all fixtures in dwelling units. That threshold now is increased to 90%. So within dwelling units, 90% of the fixtures are required to be high efficacy. You know, this is pretty much LED bulbs are now really prevalent on the market. So most of these LED bulbs can fit into this fixture. So it's really pushing lighting to become LED and away from, you know, any sort of fluorescent. There's still that 10%, you know, that don't have to be high efficacy, and you know, that's typically used for decorative lighting within dwelling units. Most of these changes that I've been going over originate from the National Model Code, the 2018 IECC, but New York State did make an important change on outdoor parking area lighting controls. So they added, they took language from 90.1 and added it to the ECC compliance path. And what these controls require is it's essentially an occupancy sensor on certain lighting fixtures that are in open outdoor parking areas. So not parking garages, but outdoor parking areas. So that, if you're designing a space with outdoor parking, that's an important provision to remember. So those are all the changes from the state code in the ECC compliance path. Now I'm going to talk about the changes that originated from ASHRAE 90.1 2016. And just also as a reminder, I didn't talk about this in the beginning, but when you have a commercial building, following the energy code, anything over 4 stories is required to comply with the commercial provisions. If it's any occupancy that's not residential also has to comply, so any story in height. There's 2 compliance paths. There's the compliance path for ECC. Those are the changes I just went over. An alternative compliance path is to follow ASHRAE 90.1. So the changes that I'm going to talk about is in this alternative compliance path. Either one is allowed for code compliance. So 90.1, the changes in the envelope section. One of the big changes is that all projects that follow 90.1 have to have requirement is envelope verification on all projects. So this requires all of the seams and joints within the building that are constructed need to be visually checked and tested. It's similar to our air barrier continuity plan that's required for buildings 50,000 square feet and greater. But 90.1 now requires a certain level of verification on all projects. So that will be something that Tier 8 agents are required to be doing. There are more stringent U-factor requirements for fenestration. However, our advisory committee really reduced the U-factor requirements even more. So I'm not going to go over those in detail here. Gina will go over those changes when we get to the city changes. Also, the solar heat gain coefficient reduced from 0.40, which it was 0.40 for at least a decade. It's now dropped to 0.36. So that is an important change as well. For HVAC, power, and other, one of the changes that was made is now a requirement that if an economizer is provided, it also has to be equipped with fault detection and diagnostics. This was a requirement in the ECC for a few years, and ASHRAE adopted this language into this compliance path. So you can see there's a lot of, ECC and ASHRAE are, becoming a lot more in alignment. They're, taking code sections from each other that weren't present before. If you're designing a chiller plant and following ASHRAE 90.1, there are a lot more stringent metering requirements for that chiller plant. There has to be, real-time metering of the electricity consumption and the, live, the efficiency rating of the chiller plant, pretty much in real time. So that's a new requirement and very important if you have a large chiller plant. There are new efficiency requirements. You'll see new efficiency tables added within the HVAC section. Some of those equipment are pool dehumidifiers and dedicated outdoor air systems. So there are new moisture removal efficiency requirements for the dedicated outdoor air systems. And also in 90.1, we think this is a really important addition to the code. For alterations, there's a new section for HVAC alterations, and the requirements are greatly expanded. So instead of the code saying, the code is applicable to essentially whatever the scope of the work is what it has said in the past, it details out a list of sections that are required and certain controls that are required for that HVAC alteration. ASHRAE 90.1 is really expanding the scope of the standard. And one of the ways that they're doing that is looking at regulating elevators. So elevators, the efficiency of elevators is not regulated yet, but ASHRAE did add a requirement to list both the usage category and the energy efficiency class of elevators in buildings. And they have said in the standard that they're staging, this requirement, they're staging it for the future edition of elevator efficiency requirements. So all you have to do now is just list the usage category and the energy efficiency class, and likely in next code cycle, there will be a minimum efficiency class that is required for elevators. And I already mentioned in the ECC provisions that ASHRAE added ventilation occupancy controls for hotel guest rooms. Previously, it was just a control for temperature. Now the ventilation also has to shut off when there are no occupants in the hotel room. And a very important requirement, if you are a commissioning agent or a Tier 8 inspector, all controls requirements previously said that if there was a controls requirement, the control had to be capable of doing X. So now all of the code language has changed to say that that the controls requirements have to be capable of and configured to that which is listed in the code. So it doesn't just have to have the ability to do it, it also has to be configured to that requirement, at the time of inspection. Now we're jumping into the lighting changes. Lighting is perhaps one of the biggest changes in this code update. So oops, I skipped a slide. Sorry about that. The interior lighting power, the change that ASHRAE has made is the overall reduction dropped by about 26% if you're using the space-by-space method. And these estimates of reduction come from the Pacific Northwest National Lab, and they're area weighted based on construction within the US. So it's not a flat reduction in interior lighting power. You'll see some spaces reduced maybe by 50%, others didn't reduce at all. But overall, if you're looking at a weighted average of construction, they reduced under the space-by-space method by 26%. Under the building area method, there's an overall reduction of 34% in lighting power density. For additional, there's a retail display allowance that reduced by 25%. I think that allowance hadn't changed in many code cycles. And then the decorative lighting allowance also reduced by 25%. So this is just the code sort of catching up with the LED market that's now prevalent and cost effective. So, that's why we're seeing these major lighting changes. It's really just the code catching up with the market. We'll talk about what the stretch code did. The stretch code went even further in reducing the lighting power densities. So similar to interior lighting power, exterior lighting power also had a major reduction by an average of about 30% for the lighting power for outside. Other changes in controls, parking area lighting controls. There's now a requirement, as I was mentioning, this is the ASHRAE language that the state adopted into the ECC. If you have an outdoor parking area, there's now occupancy controls that are required on certain lighting fixtures in that space, and then outdoor, parking area. The code now is very specific for interior alterations. It talks about what lighting controls are required for compliance for alterations. So that is the occupancy sensors, scheduled lighting shutoff, daylighting controls, and bi-level switching. So for each space, the code says which is required for new construction. If it's required for new construction, then the alteration, must comply with these four. If one of these four is present, that alteration of that space must comply with those. And then for exterior lighting alterations, photosensors and scheduled shutoff controls are also a requirement. So that pretty much wraps us up for the changes that come from the state code. And, remember that anything that comes from the state code is not under our authority of jurisdiction to vary. So any variance that would be required from the state code has to go to the state for approval. So now I'm going to get into the provisions that were adopted from the NYSERDA NYStretch Energy Code 2020. So just high level looking at these changes, I have some slides on, going into a deep dive on each one of these and what it means. More stringent installation requirements. So the commercial energy code installation requirements have not changed much in the last several code cycles. So they're now changing slightly. It's not a major change. The stretch code also added more stringent fenestration requirements. However, the city advisory committee went even further on that. So Jean is going to talk about that, about the new fenestration requirements under the city provisions. There's now a mandatory thermal break for all balconies and parapets on new construction. And so I have a few slides on what that means, what it looks like when it's required. And then air barrier commissioning is now required on all buildings greater than 10,000 square feet. So, this essentially means there has to be, there has to be some sort of verification plan that's happening on buildings greater than 10,000 square feet. In addition to this, buildings also, are required, and, we'll get into this under the city code provisions, but certain buildings are required to do whole building air barrier testing, pressurization testing, and also we'll get into details on what the air barrier continuity plan means. All right, so looking at the specific installation increases. For roofs, for above deck assemblies, it increased from R30 to R33 continuous installation. So just slight increase there. For attic and other, it increased from R38 to R53. So this is quite a big jump. However, we don't see under the commercial provisions very many attic construction. That's usually typical under the residential provisions, which I think is also more stringent than the commercial provisions. So it's a little higher than R53 under the residential. For above grade walls, mass walls have increased from R9.5 continuous to R11.2. So that would be mass walls for any occupancy that's other than group R. For mass walls that are, with group R occupancy, it increased from R11.4 continuous to R13.25 continuous. So again, you're seeing about an R2 increase across, mass wall construction. For metal framed walls, the previous requirement was R13 cavity insulation and R7.5 continuous insulation. That continuous insulation requirement is now up to R8.5 continuous. So, again, small increase for metal frame walls. For floors above unconditioned spaces, quite a big jump here, going from R10 to R14.6 continuous for anything but group R occupancy, and R16.7 continuous for group R occupancies. And then for heated slabs, remember I mentioned in the state code that R5 is now required for underneath the entire slab, right? So now for heated slabs, R20 is required at 4 feet below at the slab and 4 feet below. That's like a vertical insulation. And R5 is required underneath the entire slab. So, and again, heated slabs are ones with heating elements embedded in the slab on grade. All right. So one of the new requirements that came from the stretch code is that, now this only applies to new construction. So any alterations do not have to do this. Balconies and parapets are required to mitigate their thermal bridging. And there's two options for prescriptive compliance, they can essentially either wrap the entire balcony or wrap the entire parapet with insulation, as you see in this diagram to the right. And if that is the compliance path chosen, the R value of the insulation that has to wrap around the element, either the balcony or the parapet, has to align with the requirement of the insulation for that type of wall construction. So for an example is for the metal wall, which we just saw was R13 cavity plus R8.5 continuous. If you choose to wrap the parapet or the balcony, that has to be fully insulated with that continuous insulation value of R8.5 in this example. So that would be the requirement if you wrap the element. The other option is that you can incorporate a thermal break of a minimum of R3. So there, for balconies, there's products on the market that, where you can have this thermal break. For parapets, you can design, a thermal break within the parapet itself. So those are the prescriptive requirement options for parapets and balconies. This measure is not, however, a mandatory measure, so it may be traded off. This is, I believe this is in one of our how-to guide examples. Gina mentioned we have a how-to guide on our website. I encourage all of you to go in there and look at, a lot of this information is covered in there, how to input things into ComCheck. So here is an example of how a parapet can be input into ComCheck. So you'll see on the left, this is a compliance option where someone has decided to wrap the entire parapet in insulation, and this meets the prescriptive requirements. So you can see they're wrapping the parapet in insulation of R8.5 continuous. So in ComCheck, if you were to use ComCheck for compliance, and your roof insulation value is R33, the entire roof would be R33 inclusive of the parapet. That's how we would expect to see it designated in ComCheck. Likewise, if the other option was chosen, where there was a thermal break of a minimum of R3 embedded in the parapet, you would still input the parapet and the roof assembly into ComCheck the same way. So you would take that area, inclusive of the parapet, and assign it the R value of the roof insulation. In this example, would be R33. Now, say, however, you decided that you didn't want to comply with either one of those prescriptive compliance options. In this case, what you would do is you would take the roof area of R33 and add that into ComCheck, and then for the parapet area, that would be an R0, or you could do a thermanalysis and have a slightly better R value that would be accepted into ComCheck. So this would be an example of how you would go forward and utilize the trade-off example. All right, and moving on to HVAC and power. So one of the requirements is that, so we are adding a requirement for elevators. It's only in new construction. So new elevator shafts. So if a new elevator shaft is created in an existing building or under new construction, and it's greater than 7 stories, the shaft height is greater than 7 stories, the elevator must be a regenerative drive. So, essentially when an elevator goes up with a light load, down with a heavy load, the system generates more power than it uses. The code now requires you to capture that power and convert it into energy that's used within the building. So that's a new requirement. These have been on the market for over a decade. So, they're widely available, but now they're required by code. Also, and this is in addition to the code as well, certain commercial kitchen equipment has a minimum efficiency requirement. The minimum efficiency requirement aligns with the efficiency requirements in Energy Star equipment. And this is really for, if you have a hospital cafeteria, if you have a school cafeteria, a restaurant, things like fryers, hot food holding cabinets, commercial steam cookers, commercial dishwashers, commercial ovens, that's all now regulated under the Energy Code. So something to pay attention to if you're designing one of those buildings. All right, and then this is the last slide I have for changes coming from the stretch code. So again, the lighting power densities were reduced significantly from the state code for both interior and exterior lighting. The majority of these lighting power densities were developed for ASHRAE standard 189.1. And I think there were all but 4 spaces that New York City adopted from the stretch code requirements. So, I think, you've been hearing me talk about how lighting has greatly reduced. So if you're a lighting designer, you definitely need to pay attention to these new lighting power densities. If you're an energy modeler and you're used to, having a lot of savings for lighting, that is not going to happen anymore. So, this is a really good change in the code, we feel, but something definitely needs to be paid attention to. There's now a new requirement for occupancy sensors in corridors and any sort of egress illumination. So essentially, the lighting has to basically shut off to the building code minimum illuminance value. So it's not a conflict with the building code. You still have to have a minimum level of lighting within the egress, but you cannot have full power lighting in your corridors and egress anymore. There has to be an occupancy sensor there that shuts it down to the building code requirement. So that's there now. There's also, so ASHRAE has had since last code update, they had a lot of fuel metering requirements and sub-metering requirements. So now whole building fuel metering requirements are required for either compliance path. So what this means is there has to be a meter for the entire building that tells you how much natural gas that entire building is using, or how much electricity that entire building is using. There's also certain sub-metering requirements that were introduced in the 2014 Energy Code that are still there, but now there's a whole building fuel metering requirement. And it's not for every single building, it's for 25,000 square feet and greater, which, as you know, aligns with the buildings that are required to comply under Local Law 97. So this is a really good requirement for new construction. It's easy to do up front. It's harder to do once the building's built. But this really sets up buildings to be able to measure how much fuel they're using, and then be able to report that for Local Law 97 compliance in the future. And then the last code change, last but not least, that was adopted from the New York Stretch Code, is there, under the ASHRAE compliance path, there is a new Appendix I. It is a requirement. It's a mandatory requirement. It's not required if you're using the energy modeling compliance path, but if you're using the prescriptive or if you're using ComCheck to comply with ASHRAE, there is now a new Appendix I. It's the high efficiency option. So essentially, it's, if you're familiar with Section C406 in the ECC, that's now a requirement under ASHRAE. So what this is, it says that the designer has to choose one option, one of 6 options as a high efficiency option. So these range from reduced lighting power density, increased efficiency for HVAC, certain DOAS systems with energy recovery on them, tighter buildings, tighter than code buildings, more insulation in the walls. So those are all options. One has to be selected. It's not really an option. It's a mandatory option. So it's mandatory to follow this Appendix I. and it's an option to choose one of those 6. However, one of those 6 is a requirement. Oh, sorry, I was wrong. I have one more slide, and this is only for energy modeling. So if you do not do energy modeling or you do not follow energy modeling path, this does not apply. But if you are familiar with energy modeling, you have a project that is choosing energy modeling, there are some major changes that have happened in that pathway. The first is what we colloquially call the envelope backstop. So there is now an envelope backstop requirement for buildings greater than 25,000 square feet. In the past, there was no, there was no minimum requirement on insulation in walls. If you followed energy modeling, you could trade off all the insulation in the walls for higher efficient lighting or HVAC. You can still do that. However, there is now a threshold that you cannot cross. And the way you demonstrate compliance with this is there is a COM check that I'll show you in later slides. I'll give you a visual of what it looks like. But there's a COM check requirement for verification, and it says, essentially, if you have a building that is a Group R building, your envelope cannot be 15% worse than the prescriptive requirements in the code. If you have any other occupancy type, it cannot be worse than 7% worse than the minimum code requirements for prescriptive for compliance. So you can still have an envelope that doesn't meet the prescriptive requirements of code and trade it off with HVAC and lighting, but you have a threshold now on how bad that can be. So that's one major change. The second major change is, when you're following energy modeling, you have 2 options for compliance. You have Section 11, the energy cost budget method, or Appendix G, the performance rating method. If you choose Appendix G, there are 2 options now within Appendix G. You can comply using source energy or energy cost. In the past, energy cost was the compliance metric. Now, either one is allowed. So this kind of gives us 3 options for energy modeling, 3 compliance options for energy modeling. And then, again, this only applies to energy modeling projects, but if there is a cogeneration system in the design, only the savings from the recovered energy of that system can be accounted for within the model. So any heat that's recovered from the cogeneration system and used within the building, that energy savings that may be taken credit for within the energy model itself, but nothing else. Nothing else can be taken credit for. So we had seen some misuse over the years of cogeneration systems. So this just clarifies how we've been enforcing cogeneration systems over the last 4 years. All right, and now Gina will talk to you about the rest of the code changes.
Thanks, Emily. All right, everybody, congratulations, you're halfway through, and we've still got a few more changes to talk through with you. Hopefully all of you are finding this very interesting, and keep in mind that you'll be able to return to this presentation in the future because it is being recorded. So, changes from the Stretch Code that have been adopted into the New York City Energy Conservation Code. As I mentioned before, just be aware that we did not adopt the New York Stretch Code in its entirety. So it's, again, a good thing that all of this is integrated into the one version of the New York City Energy Conservation Code. We have had a few questions from people asking about the New York City Stretch Energy Code. There isn't a Stretch Energy Code for New York City. It is all integrated into the one NYCECC. So you'll only have that one document to look at. So let's talk about the changes to the envelope. We have new requirements in the city that increase the attention that we're giving to thermal bridges in the envelope. So not only does the Stretch Code tell us that you have to insulate parapets and balconies, our code in New York City also requires that you start looking at thermal bridges in other parts of the envelope. So we'll get into more detail on that. We also added a table that includes default U factors for spandrel panel assemblies. This is mainly because we have seen a lot of evidence in the past that there's not a lot of consideration given to the U factor of the spandrel panel, and sometimes users actually get the spandrel panel confused with fenestration. Talking about fenestration, as Emily mentioned, we actually have more stringent fenestration U factor requirements in the New York City Energy Conservation Code than were adopted in the Stretch Code. So we will go over those. And we changed the air leakage testing requirements in New York City and dropped that threshold from 25,000 square foot buildings to 10,000 square foot buildings. And again, we're talking about buildings that are less than 75 feet in height. Finally, one quick mention, we have eliminated the air curtain exception for vestibules in New York City. And let's get into the details on these envelope changes. So for fenestration, our U factors in New York City are now material dependent. So you need to look at the frame construction when you are selecting what U factor you're trying to meet. We have more stringent requirements in New York City for the fenestration below 95 feet. So mainly we have much taller buildings in New York City, so we have more stringent structural requirements for windows that occur up where wind loads are greater. So above 95 feet, there are different U factor requirements where it is a little bit more difficult to achieve the overall assembly, more stringent U factors. So if a portion of your window unit falls below 95 feet and a portion of it is above 95 feet, that window unit will be subject to the requirements for the 95 feet plus requirement. Let's take a look at those. So for non-metal framing window units, we typically see those falling below 95 feet. That U factor has been reduced to 0.28. As you can see previously in the 2016 code, that was categorized as fixed and operable. And for operable windows, that's quite a improvement in performance. For metal framing, fixed windows, below 95 feet, the U factor requirement is 0.30. Above 95 feet, the U factor requirement is now 0.36. So you can see that below 95 feet, that is also a pretty substantial increase in the performance. For metal framing operable windows, below 95 feet, that U factor is 0.40. It was 0.45. And above 95 feet is 0.42. So again, this is a pretty substantial increase in the performance. For curtain wall, at all heights, the U factor has dropped from 0.38 to 0.36. Again, these products are widely available on the market, and our Energy Code Committee was really motivated to improve the performance of fenestration for this version of the New York City Energy Conservation Code. So this is a pretty big change, and we are looking forward to how this impacts performance of new buildings in New York City and existing buildings when they improve their windows. And moving on, we mentioned that there is a new table for spandrel U factors. Again, we've seen a lot of creative approaches to determining the U factor for spandrel panels in the past, and we've pointed to a table that was created by the state of California for California Title 24, which is their equivalent energy code. So this is a table that has been in use for some time. And that table is now C402.1.4.2. The table tells us what frame type the spandrel is and what type of panel material you're using, and then looks at what the insulation value is that you're using between the framing. So if you go to the table and you look up your assembly type and it's not described there, there are a few instances where a therm analysis is required. So you have to be able to show us how you have gotten to the U factor if it's not in the table. Unfortunately, assemblies with back pans are not covered in the U factor table. We realize that spandrels with back pans are very common. Unfortunately, we were unable to find a resource that had default U values for spandrels with back pans. So if you have a back pan spandrel assembly, you will have to use therm in order to calculate that U value and demonstrate it to the department. And then assemblies with no insulation also require a therm analysis because they are not covered in the table. So let's look at the table for an example. You can see in the column on the left, you have the frame types. You would select the frame type that comes closest to describing your panel assembly. And then the second column in the middle there is the spandrel panel material. So you can see that each of the rows has a description of the types of materials that you might expect to use. So a single pane of glass or a stone or metal panel. Then you could have a spandrel panel that actually has an insulated glazing unit without any low E coating. Or you could have a spandrel panel that really looks like a seamless part of your curtain wall assembly. It might have triple or low E insulated glazing. And then in the column to the right, you see the R value of the insulation material that you're using behind that spandrel panel. And the lowest R value that you can take into account in this default table is R4, and it goes up to R30. We do not allow you to extrapolate beyond R30. You'll have to do a therm analysis. And as I mentioned, if you go below R4, then it's essentially a non-insulated panel, and you have to do a therm analysis for that panel too. So you would use this default U factor for an assembly that is described, again, in the first two columns as your default value. If you have an assembly that is described here, but for whatever reason you feel is performing much better than the table, again, you would use a therm analysis to show us how you came to a different U factor. Hopefully, this will streamline review both for our applicants and for our energy code plan examiners and help us get through these spandrel reviews faster. We also mentioned that the city has expanded air barrier testing. So we have dropped, again, the threshold for blower door test in commercial buildings from 25,000 square feet down to 10,000. And we've determined with our committee's help that it's very cost effective to do a blower door test in these smaller buildings and really helps you identify where you may have deficiencies in the envelope at a time where you're able to correct them instead of after the building has been occupied. Our two buildings, I do want to point out, have an alternative testing procedure that they may follow. It's described in section R402 and was written by the state. So we will allow that methodology to be used for blower door testing in our two buildings. And I also want to point out that another change that we made is for the buildings that are greater than 75 feet and that are greater than 10,000 up to 25,000, they can do an ABC plan or a blower door test. Likewise, buildings over 25,000 square feet greater than 50,000 square feet also have that option of doing a blower door test if you have a way to do it. Let's move on to our discussion of thermal bridge documentation. Again, I want to emphasize that this is a documentation requirement. It is not a requirement that a particular assembly has to meet performance-wise, unlike the thermal bridge provisions of the stretch code for parapets and balconies. This begins to look at other thermal bridges that are commonly in the thermal envelope and asks applicants to document them across their design. So what is a thermal bridge? Again, we're talking about any area of an assembly where there's a highly conductive material that's interrupting the insulation. So it's an area that has higher heat transfer, and it effectively reduces the performance of the thermal envelope. But the code actually doesn't consider the effects of thermal bridges outside of assemblies for many parts of the building. It's only a kind of taken thermal bridging into account in clear field thermal bridges that are described in Appendix A of 90.1. So this is a bit of a change, but again, this is a documentation requirement, not a performance requirement. The reason why we're approaching it this way is because it's a pretty big change for the design community just to call these areas out in their drawings. In addition to that, we don't have any support for thermal bridges in ComCheck and ResCheck. So in order to do that, we need the federal government to catch up to this concept of calculating thermal bridge deficiencies. So our first step in 2020 New York City Energy Code is just to require that these thermal bridges be identified in the set of drawings. And then beyond 2020, we may begin requiring that these thermal bridge performance calculations be done and that they're corrected so that there's some kind of way of remediating them. There is a provision being debated in ASHRAE right now that will do just that. So this is a way of preparing the industry for something that we believe is coming. So what types of projects have to provide this documentation? Excuse me, it's all new buildings, both commercial and residential. And then when we start looking at additions to existing buildings, they also must include this thermal bridge documentation in their application. Any alteration to a building where the building envelope is part of the scope of work, these thermal bridges also should be called out. So that's for both commercial and residential buildings. So what are we looking for? There are three different types of thermal bridges that we want to be identified on the plans. First is the one that I've already mentioned, a clear field assembly. A clear field assembly is an area of a wall, for example, where we have a regular disruption of the insulation, like framing. Those have been taken into account in ASHRAE Appendix A. So those types of assemblies are usually already derated for the thermal bridge. A second type is a linear thermal bridge, and that's a bridge that disrupts the wall in a linear fashion. And then there's a point source thermal bridge. So that's some type of element penetrating this assembly and interrupting the insulation. So you can see the three types illustrated in the slide. Again, clear field assemblies are most of the time already factored into ASHRAE 90.1 Appendix A. So there are assemblies that are clear field assemblies that are not well described in Appendix A, and those clear field assemblies should be noted in the drawing. So some examples of clear field assemblies that are regularly accounted for in Appendix A would be a mass wall with brick ties, some different types of cladding, with angles that offset it, and then metal studs in a framed wall. Those are examples that are covered in Appendix A. Something that isn't covered well in Appendix A, for example, is a Z-gird. Let's talk about point thermal bridges. A point thermal bridge needs to be noted on the drawings when that single point of interruption is 12 inches or greater. That's for commercial buildings. Just so you know, in our residential code, it's 8 inches or greater. So any kind of penetration through the insulation that affects that small area needs to be noted on the drawings. These are not areas associated with HVAC or electrical penetration, so those you can ignore. An example would be a structural beam penetrating through insulation in an assembly. And then finally, the linear thermal bridges are also described in the table and must be documented. You need to call out what type of linear thermal bridge you have. So an example might be a brick shelf angle. Then you need to, in the table, calculate the length of each of that type of bridge throughout your entire envelope. You need to have an identification to a detail that shows a cross-section through that thermal bridge, so that when the plan examiner looks at your table and wants to make sure you've documented your thermal bridges, they'll be able to quickly and easily find that detail. And then there is a psi value. In the code, there is a table with psi values for common thermal bridges that we would like to be identified in the drawing. If there is a psi value that you think does not represent your detail, maybe perhaps you've improved upon it, you can do a therm analysis and submit a different value. But again, I want to emphasize this is for purposes of documentation only and not performance. So that is entirely up to the applicant. Again, some examples would include shelf angles, slab edges, balconies, parapets, window interfaces. And so let's look at the table that is provided in the code. So you'll in the code, you will see a description of the linear thermal bridge type that you must document. A few that need to be documented are balconies, fenestration perimeters. Sorry about our slide reconfiguration there. And shelf angles within a masonry veneer wall. You can see that this calls out the total linear footage of that type of element for the building. It identifies where the department would be able to find a cross-section detail through that element, and it includes the psi value of the element within your design. And then you can see how these types of elements have been called out in some elevations that you can note where they are located within the building. There are a few other changes from the city that we would like to make sure you're aware of. There are very minor changes to HVAC efficiency tables all throughout any equipment regulated by ASHRAE. If the federal efficiency standard was higher than the 90.1 table required at the time of publishing, it has been brought up to the current federal efficiency standard within the New York City Energy Conservation Code. So that makes sure that the equipment being installed in New York City is at the highest standard required by the federal government and not lower. And as Emily mentioned before, we now have a requirement for additional energy options under ASHRAE, but they also existed within the IECC before. While we have coordinated with the stretch code requirements for this section, We do have local laws 92 and 94 in New York City that require all new roofs to have either a green roof or solar panels. So under our version of the additional energy efficiency options, the option to take extra credit for renewable energy was not included. So you can't get credit for something that is required. Finally, we've also expanded commissioning requirements in New York City for alteration. So, and under the 2016 Energy Code, there was a capacity trigger for either heating or cooling for the new equipment being installed in a space. But under the 2020 code, that capacity is called out for the size of the equipment serving the space that's being altered. So if you have a large area in an existing building where the system may be reconfigured, but not necessarily the equipment servicing the space, all of the equipment that is being connected may require commissioning. So we're talking about VAV boxes, reheat units, those types of equipment may be required to be commissioned under the 2020 New York City Energy Conservation Code. And I'd like to congratulate everybody because you've gone through now all of the major changes to the Energy Code. And Emily is going to walk everyone through the resources that we have updated and the updates to the Energy Code forms.
All right, thank you, Gina. So I've mentioned this already, and I'll mention it again. If you have not had a chance to visit our Energy Code page, we have an Energy Code page on the DOB website. Please go there because we have many, many resources that we have updated for the 2020 code. Some of them include, like I mentioned, the mechanical sections, the comparison between the 2016 code and the 2020 code. We also have an updated how-to guide with many examples on how to apply the requirements that Gina and I have just gone over. We have examples of the thermal bridging documentation. We have examples of how to input parapets and balconies into ComCheck, the ones that are required to have continuous insulation but choose not to. We have, information about energy modeling on there, and we break it down into envelope, HVAC, lighting, residential, and other requirements. So please check that out. We also have Excel forms with a sample tabular analysis. We have one for residential, we have one for the commercial ECC provisions, and we have one for the ASHRAE 90.1 provisions. So please check out our resource page. So I'm going to go over some changes that we made to the TR8 form. You'll see the image on the right. Everything in red is a change. And if it's scratched out, it was from the previous version of the TR8 form. Now, I should mention on our website, we have the 2020 TR8 form, which should go with every 2020 project. And we also have the 2016 TR8 form that is there also on our website. So this should be used for projects complying with the 2016 code that are, have finished an inspection and need to sign off. That form is still available for you. But for any project complying with the 2020 code, the new TR8 form, the 2020 TR8 form must be used. So you can see in the administrative section, we just added a few, we added, the bin number is required for the project. We now require an email address. I can't believe we didn't have that on there before. And, as far as the technical inspection changes, we just made a couple of minor grammatical changes, the first two, but the major ones, we removed the inspection for loading dock weather seals. This wasn't an inspection we saw very often. And also it's still a requirement to check these loading dock weather seals, but it really falls into one of the air barrier categories. So it's not that it's not an inspection requirement anymore, it's just that it doesn't have its own inspection line item on the TR8. And the other thing that we did is we made it a lot more clear, which air barrier compliance option is required on the project. So previously we either had only visual inspection or testing, and it was very confusing if a project had to follow the air barrier continuity plan, which is really a combination of visual inspection and testing. It was just not clear to applicants on which inspections should be selected, and we weren't consistent on our enforcement of that. So we've made it a lot more clear this time around. So what we did is we have now 3 options for air barrier. So we have air barrier visual inspection, right? So this should be for every project that is less than 10,000 square feet. And then we have air barrier testing. So this is the whole building testing or blower door testing. Now this is required for buildings 10,000 to 50,000 square feet, less than 75 feet in height. So if you have one of those buildings that you are designing, then this inspection must be checked. We also have an testing or TR8 inspection for air barrier continuity plan testing. So this is for projects that are 50,000 square feet and greater, and also for projects that are 10 to 50,000 square feet greater than 75 feet in height. So one of those options should be selected. In our how-to guide, I strongly suggest you look there. We have a whole page dedicated to which inspection items are required for different testing. Sometimes it gets a little confusing if you have a residential building and you're doing sample testing. So we have a couple of different scenarios and which TR8 inspection items apply when. So please check that out. All right, under the HVAC section on the TR8 form, we added a new inspection for a mandatory residential ventilation. So in the past, residential homes were only required to have exhaust ventilation. Now the Energy Code requires that they have either balanced ventilation or an ERV. And that there's also an inspection component to this, almost like commissioning. Again, this is for the residential provisions, 3 stories and less. That's not what we covered today. We'll go into that at 3 o'clock this afternoon. But just for your information, on the Tier 8 form, there is a special inspection item for that requirement. So that would apply to all residential new construction buildings. And let's see, we changed the, we essentially desegregated the piping inspection and the duct inspection requirements. So if you see the last 2 lines of, on this slide, we used to have a separate testing requirement just for duct leakage testing. We found that wasn't often used. So what we did is we have an inspection for HVAC and service water piping design and installation. So any piping and the service water piping design, which is a requirement that was added in the 2016 code, and it really dictates the length of pipe you can have or the volume of water inside the pipe you can have between the hot water system and your tap and hot water faucet. So now there's a dedicated inspection for that, plus the installation on all of your HVAC and service water piping. So, so there's one inspection for the piping design and installation, and then the inspection below that used to be just for duct leakage testing, and now we've added all the installation and design there. So any ducts you have that require insulation, and we added the duct design on there because there's certain requirements in the residential code on how that needs to, on certain duct requirements for certain duct design requirements. So that's all lumped in together. right? So those are desegregated now. We made changes in the lighting and power section. One change that we made is previously we had an inspection called electrical energy consumption, and this was for electric submeters, meters, and things like that. Now we have a whole building fuel meter, so it's not just electrical metering. So we've just changed the wording there. We also added under electrical motors, we also added the elevator inspection there. So we have electrical motors and elevators. So that's for your regenerative drive. If you have an elevator that, you know, has to comply with that requirement, that's the inspection that would be chosen. And then the very last requirement, this only applies to residential provisions. There used to be a solar ready requirement, but local laws 92 and 94 now require solar or green roof on all projects. So we removed that provision from the energy code because it's now required to have solar, not just be solar ready. But what we did adopt from the stretch code, again, for residential provisions only, we adopted the electric vehicle service equipment requirements. So this means every parking space that's associated with a residential building is required to be electric vehicle ready, has to have either a charger or has to have either an outlet, sorry, not a charger, either an outlet or panel space and conduit for the future installation of an electric charger for an electric vehicle. So that's a new inspection requirement. All right, so those are the TR8 changes. Again, that form is up on our website, easily accessible. The 2016 form is still there if you need to use it. So as we've gotten quite a few questions on, how do I input certain things into ComCheck, especially fenestration. So I have a few slides on the major changes in ComCheck. So I'll go over that now. All right, so first off, it's very important to make sure that the latest ComCheck version is being used for your project. The latest version just came out last week. There are still some bugs that PNNL or Department of Energy is fixing and updating. So it's very important to check energycodes.gov, the ComCheck page, and download the latest ComCheck software. The latest version is 4.1.4.2. It just came out last week. I think we mentioned several slides ago that ComCheck is only updated with the 2020 code for the desktop version. The web version of ComCheck does not yet incorporate the 2020 code provisions. Department of Energy and PNNL is working on this, but they have not yet released the web version. So if you are complying with the 2020 energy code using ComCheck, you must use the desktop version. I think one limitation to this is that is not compatible with Macs. So that's an issue that we've heard. Unfortunately, we can't do anything about it at this time. But Department of Energy is working on a web version. It should be released later this year, but I don't yet have a date on when that will happen. All right, so when using the latest ComCheck version, when you go to code, you go down to New York City, and you will see 4 options for New York City code options. The first one is 2016 NYCECC. So if you have a prior project that you're still, working through to get approval, or you're making PAA changes to it, that's still there for your use. We've been getting questions, is there a 90.1 available for the 2016? That was never updated for 2016. So it's only the 2016 energy code that was updated. For the 2020 NYCECC, we have 3 options. So the first option is the 2020 NYCECC that follows the provisions that originate from the state code. The second option we have is the 2020 NYCECC Appendix CA, or the modified ASHRAE 90.1 2016 version. So this is the ASHRAE compliance option. And then the third one is only used for energy modeling projects. So this is the 2020 NYCECC Appendix CA Modeling Envelope Backstop. You do not need to select this if you're not doing an energy model. However, if you are complying with an energy model, you must perform the energy model, fill out the EN1 form, which I'll go over in a few slides, and submit this ComCheck, the 2020 NYCECC Modeling Envelope Backstop ComCheck. All right. So other major changes in ComCheck, we mentioned that there is now the high efficiency option, so for the ASHRAE path. So when you select the Appendix CA, modified 90.1 2016 version, you'll see the efficiency option that pops up. And here it's mandatory to select one, and then you have your option, your high performance HVAC, reduced lighting power, enhanced lighting controls. You select one of these, and that'll be your designation for the project. If you select high performance HVAC or reduced lighting power, the minimum efficiency values within ComCheck will automatically update or populate. Everything else is, you'll have to provide additional supporting documentation to show that you complied with those requirements. And that's the same under the ECC path as well. All right, for fenestration, we were getting some questions in the chat box today about how to input the fenestration requirements into ComCheck. Now that we have different U factors for below 95 feet and above 95 feet, so the way that, it's input into ComCheck, so one additional requirement you'll have to do is input the overall building height in feet above grade. So that's a new requirement. So that's the total building height. So input that, and that will affect both the fenestration, and it also will, provide the correct air barrier testing requirement. So we have requirements that are different for below 75 feet and above 75 feet. So that's what this new value does in ComCheck. When you go to the building envelope area type, when you're inputting your the U factors for your walls and windows, when you select the window, you'll see under metal frame, now you have 4 options. Instead of just fixed or operable, you have fixed below 95 feet, fixed above or equal to 95 feet, operable below 95 feet, operable above or equal to 95 feet. So for each different window type, one of these needs to be selected. And then in your supporting documentation, in your construction document set, it's very important to have an elevation, diagram of your building with a 95-foot demarcation line. So it's very clear to both the examiner and the inspector which windows are below 95 feet and which ones above 95 feet. So that demarcation line, that 95-foot demarcation line, is now a requirement that is in our Rule 5000-01. So it's important to note that. So when you select that and you do your ComCheck report, this is how it will appear. So you'll have your, by orientation, this should all look familiar. This should all be the same, right? It tells you what type of fenestration assembly you selected and your performance specifications. And then it indicates whether it's below 95 feet or above 95 feet. And the U factor is adjusted accordingly. So that's an additional, that's something that you'll need to start paying attention to. So that's a pretty big change for the fenestration requirements. But the good thing is it's all built into ComCheck, so it should be pretty straightforward once you get the hang of knowing where these selections are located. All right, and then I don't have any slides on this, but just to go over that, we covered a lot of changes in the 2020 code. Most of those changes in ComCheck appear in the inspection checklist at the end of, when you run your envelope HVAC lighting reports, there's an inspection checklist that's generated. Most of that information is in that inspection checklist. So it's not actually embedded in the, in the programming or the algorithm part of ComCheck. It's in the inspection checklist. We do not require the inspection checklist to submit, with your plans. but we do require that information is listed in sort of a tabular analysis format. So it has to be, documented on your construction document somewhere, either in a tabular analysis format. We're calling it a supporting documentation index. We have examples in our in Rule 5001. We also have examples of what that looks like in our how-to guide. That's required in addition to ComCheck. So ComCheck doesn't give us all the information unless you have it in the inspection checklist on whether or not you meet all of the prescriptive and mandatory requirements. So keep that in mind when you're submitting your documentation. All right, and then this is just what the ComCheck version for the modeling envelope backstop looks like. You'll see the energy code selected here is for modeling envelope backstop. And, you fill out this ComCheck the same way that you would for, just compliance for any other project. It's important you use this because the baseline values or the code values differ under the modeling backstop versus, just the Appendix CA, the amendments to 90.1 2016. And then what's nice about it here is it either tells you whether you qualify for the envelope backstop or you don't. So for this particular example, a green banner shows up and it says, oh, your envelope design is 9% below code requirements, but the allowable margin is a negative 15%. So you have negative 9%, which is better than negative 15%, therefore you qualify. So this is a requirement to submit this documentation along with your energy model and EN1 form. All right, we made significant changes in our EN1 form. Again, this is just for energy modeling. Our form is on our website. It's Excel based. We've color coded the form, so anything that's in green is basically an automatic formula. It's a formula and it's automatically populated based on your data inputs. So we've added a tab in there for Local Law 97 calculator. So it basically takes all of your the modeled energy data from your EN1 form, and it tells you whether or not that this building that you modeled using all the assumptions you did in your model, and you came out saying this is how much energy you would use on an annual basis. It tells you whether that value, whether that building would be within the limits of Local Law 97. So this is just a high-level check. It's not required for compliance. It's really just for informational purposes. But we felt like it was something that the industry needed, just basically for more information purposes. So that's a new tab in the EN1 form. I mentioned that Appendix G now allows compliance with source energy in addition to energy cost. So now if you're following Appendix G for compliance, you'll see that there is, compliance metrics for performance cost index and then also for performance source energy index. And those are all auto-populated with the green cells. We made another change to it's called the weighted BPF calculator. It's a building performance factor calculator. One issue in our previous EN1 form is that, these space classifications that are defined in the code, we'd see a lot of multifamily buildings, but the entire building wasn't multifamily. You'd have multifamily and maybe some retail, or, or multifamily and maybe some office space. So this little calculator, it's just very simple. You just input your modeled area for all the different space types, and it gives you the weighted BPF, both in energy cost and source energy, now that that's an option. We've also added this information for the envelope backstop. So you have to submit your ComCheck compliance form. You also have to enter the values from the ComCheck compliance form into the EN1 form. So we use this EN1 form to to collect data from the project. So it's important that this is filled out. So another change that we made to most of our tabs is you see a lot of yellow cells. These yellow cells mean you need to fill out this cell in order to submit this for compliance. In the past, we got a lot of EN1 forms that were not completely filled out. So to try to avoid that issue, we've highlighted them yellow. So once you start typing in there, it'll turn white or blue if it's a drop-down menu, but you'll see lots of yellow now in the EN1 form. So on the lighting tab, we added one of the new space types we have in the code. I don't know if we mentioned that earlier, but if you have, like a core and shell building, the unfinished space in that building for the post-construction build-out is now assigned a baseline value of 0.2. There's a lot of confusion on what that LPD should be, and there is, a lot of savings was trying to be taken if it was, supposed to be an office space, but the lighting wasn't yet designed. So, so now we have a baseline value of 0.2 for those unfinished spaces. And we also added some new columns for the additional lighting power allowance. So if you have decorative lighting or retail lighting, or you're taking allowance for your room cavity ratio, any other additional lighting controls, there's now an option, or there's now space in the EN1 form to designate that information. The biggest change we made was on the HVAC section, and we automated, we created a macro to automate, partially automate the HVAC section. So essentially how this works is, so for anything that's in blue, it's a drop-down menu. So proposed system design, this needs to be selected. So, whatever type of HVAC system you have, you select one, per row. So if you have VRF system, you select the VRF. Or if you have a packaged air conditioner or rooftop unit, you select that. Packaged terminal heat pump, you select whatever your proposed system design is. And then we want to know what you called it in your mechanical schedule. And then we also want to know what you called this system in your energy model baseline reports and also in your proposed reports. So, if we can get this information on how these, the names of these mechanical equipment tie back to the drawings and the modeling reports, it saves a lot of back and forth between our examiners and the design team. So once that information is input, these purple cells are automatically populated, but they are also drop down, so you can change the selection. So for example, if you choose a VRF system, it auto populates to single zone residential. It's also a drop down menu. You can change it to a single zone non-residential, or if it is a multi-zone, you can select that as well. And then you'll have the baseline system that correspond to section 11 that automatically populate here. If you have just an Appendix G project, that's when you use this pink column. So we have a tab within the EN1 that has very detailed instructions on how to fill out this form. So it can get a little complicated, but we try to really identify step by step on how to fill this out. So once you fill out this section, there's a button you push that says I'm done, and it takes all this information and automatically populates it into the airside HVAC. So you see everything that's in green is automatically populated from the previous tab. Everything in yellow needs to be filled out by the user. And then anything that's in blue is also a drop-down. So, this was really to just reduce a lot of errors and back and forth that we've had, with the design teams and, and the plan examination staff. So hopefully this will help our energy model reviews go a little bit quicker. All right, and with that, Gina will close us out with what to expect in the future of Energy Code.
Thanks, Emily. So this is a lot of information. Hopefully you guys have found it really useful. Let's talk about where the code is going next. So again, I mentioned earlier in our presentation, Local Law 32 of 2018. It mandated that we had to adopt the New York Stretch Code for 2020, actually for 2019, and the state was a little bit delayed. So we do know that NYSERDA is working on the next version of the stretch code. Hopefully that will be completed, and then in 2022, if the state goes back to their original schedule, we will adopt the next version of the New York State Stretch or New York Stretch Code. Hopefully, if that's available, that will make our process easy. If not, then we'll work with our committee as we described in the beginning, to try and get to that 20% better than ASHRAE 90.1 2013 with the next version of the New York City Energy Code. However, Local Law 32 also requires that in 2025, we completely depart from the national model codes using ASHRAE 90.1 and IECC, and going with a absolute energy metric for performance. So for buildings that are 25,000 square feet and greater, we anticipate under the 2025 code that there will be a requirement for energy modeling or some other performance path, and it won't be ComCheck or ResCheck anymore. It will be a new way of complying with code. So at that point, we may be looking at metrics like energy use intensity or EUI, or we may be looking at carbon and GHG intensity. Things will change quite a bit in 2025, and hopefully our 2020 and 2022 codes will get us the kind of energy performance we need to make that transition a little easier for everybody. For buildings less than 25,000 square feet, Local Law 32 does not mandate a new code process, so we will have the national model codes, the state code that everybody's used to using will be in effect for those smaller buildings. And then in addition to Local Law 32 and the changes that it has mandated to our code adoption process, we also have Local Law 97 of 2019 that was part of the Climate Mobilization Act. Local Law 97 affects buildings that are greater than 25,000 square feet and sets greenhouse gas emission caps on those existing buildings. So this is not just new buildings, but all buildings over 25,000 square feet. And so beginning in 2024, owners must stay under that greenhouse gas emission cap, or they may be subject to a fine. So over time, the caps will come down. In 2030, they will be reduced. And about 75% of existing buildings that are over 25,000 square feet don't comply with those caps based on their energy consumption right now. So existing buildings will have to make improvements over time. But our point here is that if you're filing a new building that's over 25,000 square feet, the code probably does what it needs to do to get you to compliance in 2024, but it probably doesn't get you compliance in 2030. So you need to be looking at how the building is going to comply with Local Law 97 in the future, not just how it complies with the energy code that we have now. And so there are resources, as Emily mentioned. Our EN1 sheet now has a tab that helps you understand whether your building is going to comply with Local Law 97. This is taking into account only what we know based on the design. So you may know very well that energy modeling does not predict how a building is going to operate once it's occupied. So you need to talk to your client and help them understand the impact of Local Law 97 on their building and on future compliance requirements. In addition to Local Law 97, which addresses our largest buildings in the city, which are about 60% of our greenhouse gas emissions for the building sector. Other buildings within the city are expected to have to do their part. So the plans for sustainability within the city have called out that we will be working towards net zero performance for all new buildings by 2030. And no legislation has been passed at this time to help us understand better what those requirements will be. But we do anticipate that additional legislation will come out in the future and will affect how buildings must comply with the energy code and with other greenhouse gas emission requirements over time. With that, we thank you for your participation today, for all of the questions that we have received in the chat. And we hope that this has been very useful for you and your work. If you have additional questions that have not been answered in today's chat, or that you think about after we finish up today, as you're working on projects, we are here to help you. You can always email us at energycode@buildings.nyc.gov. Send your questions to us and we will be more than happy to assist you. I think we have just a few more minutes to take questions on the chat. And we hope everybody stays well and has a great day.